Welcome back to my channel BK Tech. Today we are going to study about the problem which is number of province which can be solved using the DFS. So let me explain you how this problem can be solved. So assume you are given with the entire graph which is 1, 2, 3, 4, 5, 6 and 7 and 8. So in this you need to find the number of province. So if you see our first province which is 1, 2 and 3. So in this, you can visit any node from any node. So let's say you want to visit 2 from 1. So here you can see uh, we can go from 1 to 2. And if you want to visit 3 from 1, in the same way you can visit first 2, then we can visit 3. So in this you can see that we can visit any node from any node. And in the same way we can visit any node from 2, and in the same way we can visit any node from 3. So this whole can be called it as a province. And in the same way we can call other 4, 5, 6 and 7 and 8 as a province. But these two, if you see, we can't call these full as a province because we won't be able to visit 7 from node 4. So this can't be called it as a province. So now we will be having a three province in this. So that will be 1, 2, 3, 4, 5, 6 and 7 and 8. But you will be thinking how we have calculated these three problems. So in the last two lectures, I have told you about the DFS and BFS algorithm. If you have not watched them, you can go and watch them first and come back to this video again. I have attached the link of these two videos in the description. Now coming back to our problem. So the problem is that how we got these three. So let's say we will be using a DFS algorithm in this. So we will be given with the starting node. So let's say suppose our starting node is 4. So we will visit 4 first, then we will visit 5, then we will visit 6. But you won't be able to visit 1, 2, 3, and you won't be able to visit 7 and 8. So what you will be doing in this case? Let's do it that let's keep 3 starting nodes, 4, 1 and 7. So now if you traverse 4 and if you traverse 1 and then 7, you will be able to visit 1, 2 and 3, and in the same way 4, 5 and 6 and the 7 and 8. But the thing in this is that how you will be able to find these three starting nodes. So for this, we are going to create one graph and keep a one visited array and traverse with the help of for loop for this DFS. Let's say all the indexes of the visited array, which is of size of the number of nodes plus 1, is marked as unvisited. So let's say we will start with the first node. If you have a starting node as 0, you can start from 0. And if you have starting node as 1, you can also start it here as a 1. So if you start with a 1, you will see it is visited or not. So you can see that it is not visited. So you will call a DFS for this and mark it as a visited. Once this is marked as a visited and it went to call a DFS call, so this will check that who are at the depth of 1. So you can see the 2 is at a depth of 1. So it will be also marked it as a visited. Now you can see that 3 is at the depth of 3. So in the same way, it will be also marked it as a visited. And now the thing is that 3 is not having a depth. So now again it will come back to this for loop and we will now again go to the 2. So it will see that it is marked it visited. So no operation will be performed for DFS. So it will traverse to other next node, so which is 3. It is also see that it is marked at visited, so it will not go for the DFS operation for this. Now it will come back to the 4. So if you see, the 4 is marked it as a unvisited, so it will perform the DFS operation on this. So in the same way, 4 will be marked it as a visited and DFS call will be made for this. So in the same way, 5 and 6 will be marked it as a visited for this. In the same way, it will traverse till the 7 and it will mark them as a visited. So now all the nodes present in the graph are visited and that will be coming to our answer array. So in this way we can find out that how many times we have called this DFS. So the number of times we have called the DFS, that will be the number of province we are having, and that will be the answer of our problem. So it will be going into the if for the 3 times. So this will be the answer of our problem. So now let's go to the solving this problem in the GFG. Here we are given with the number of province problem, which is a medium problem, and here you are given with the inputs in the form of array. So if you see at a one index, you can see that one is present. At two index there is zero, and at third index you can see at a one. In one based indexing, basically I'm talking about in this. But so if you see that on the index of 1 and 3, you can see one. So 1 and 3 are connected. So here we can see in the diagram that 1 and 3 are connected. But in input, if you see that at the second index, in the second position, there is no one other than the position of that second index, so the 2 is alone. So in this form the graph is formed. So first of all, what we need to do here is that we need to convert this input array into the our index adjacent matrix. So we are going to take one array list which will be of type integer. Now what we are going to do is that we are going to put the array list object in this whatever the adjacent list we have created. So we are going to put a one array loop. This will run till the number of edges we have. You can see that vertices we have, sorry, not the edges. So we have added the objects of the array list. So now our adjacent list is ready. We put the our nodes into this adjacent list. So we are going to put two for loops for this, which will run from 0 to v, number of which v represent as the number of vertices in this. So if the 1 is present at the index of the 0, then only we are going to put that into our adjacent list. Otherwise we are not going to put it into the our list. So like we are going to check from the adjacent matrix that if 1 is present or not. So adjacent of I in sorry, for array list we need to use get. So at the I, if 1 is present. And one more thing is that, like you can see in this, is that at second index only the 1 is present, but other than that nothing is present. So here you can see that if I is equal to j and I should not be equal to j here, then only it should add element to our adjacent list. First we need to get the our uh, whatever index of the adjacent where we need to add. So we are going to get it at the ith where I need to add, and dot add j where we found it that it is equal to 1. And in the same way we need to do otherwise vice versa also, that at the jth position of our adjacent list we need to add this I. Here we are, you can see in the diagram they are using one based indexing. We can also use the zero based indexing, indexing because we don't need it 1 2 3 in our question to solve this question. Then we are going to call this adjacent list and check wherever we are founding the unvisited. So we are going to first create a one visited array for this, which will be of size v. Now we are going to traverse this adjacent list. Sorry, we are going to traverse the number of vertices here if we correctly go for that. So if that node is unvisited, then we are going to call our DFS where we can have this adjacent list. We can have this visited array and we can have this node. And then we are going to create one DFS function where we can have this array list. Then we can have one visited array. Then we can have one node. So whenever we get any call, we need to first mark that node as a visited. Then we are going to apply one for each loop. Dot get. We are going to get that node into this the list that who are the adjacent of that node. So we are getting in this for loop. If it is unvisited, then only we are going to call again a DFS where our adjacent list will be same. Visited array will be changed with the this current node marked as a visited, and we are going to call next with the ID. And one more thing is that as we are calculating a number of province, so we are going to maintain one count of the number of province. And the number of times this loop visited this if condition, we are going to increase the number of province. Uh, so this is the code which we required for this DFS problem of number of province. In this way you can calculate the number of province. Now we can compile this problem. So here now we have clicked on compile. So now you can see that the code has been compiled, and now we can submit this. So yeah, you can see that most of the test cases is passed. Uh, Thank you for joining.